Gunton, hopefully I said that properly.
Gunton, yeah.
Gunton, for presenting design for guidance in machine learning. And once again, when Olivia's done speaking, I will be taking questions live on Twitter for this session. So, thank you, Olivia.
Hi, everyone. Great to see you all here. As you just heard, my name is Olivia Gunton, and I'm a data scientist at Textio. We're an augmented writing startup in downtown Seattle. And to give you an idea of what augmented writing is about, imagine if every time you wrote something, you knew who was going to respond and why. And that's what Textio is all about. So today I want to tell you about what I think is a really cool and interesting design question that we have to grapple with, which is when you're designing a system that's based in machine learning, how does your design decision have to change if you don't just want to be good at predicting outcomes from inputs, but you also want to be able to give real-time, automated, actionable guidance to humans? So to frame this, I want to talk about some different styles of machine learning that we've seen over the years. I think when a lot of people think of machine learning, they think about the one on the left here, the black box style. The idea is that with all the processing power that we have, we want to let our models become as complex as they need to be most predictive. So an example here from the user perspective is the Google search ranking algorithm. If I enter a search term into Google, I'm not seeing information about why the #1 page is ranked as #1. And that's by design, and maybe I don't even want to know that information. What's most important to me is that the page that I want to click on? But then when we start to apply machine learning to scenarios where the risk of making a bad recommendation is much higher, then we start to have a requirement for our models to be explainable. And I'm using Waze as an example here because it's an app that we probably all have on our phones. So when you see Waze's recommendation about what route you should take, there's a lot of information in there about some of the reasons why it's recommending that route. And that might include properties of the route as well as information that's been added by the users. But another great example of this is the book recommendations in Amazon. So when you're looking at one book or you've bought something, you see a bunch of lists at the bottom that say, people who bought the book that you just bought often buy this other book. So that's giving you insight directly into why this recommendation is being made and why you should trust it. And I think as we start to apply machine learning more and more to even more high-stakes realms like medicine, we see a lot more need for our models to be explainable. We need to know exactly why they're making the predictions they're making. We need to know when and whether we can trust them. And we need to be able to fix those problems if it's making an error in a place that we really care about. So I want to argue that there's a third type of machine learning, and that is when you not only want to introspect on the model, but you want to be able to automatically give guidance to people. This is coming up in a lot of applications where we're using machine learning for human productivity tools. And I guess the characteristics of these applications is a lot of what affects the outcome is almost human art and judgment as well as skill. So our example in Textio is writing. When you write something that has an outcome, like a job description like you see here, it matters what kind of patterns are going to be predictive of good outcomes. And you also want to be able to preserve your unique voice as you're writing it. You don't want to just have some program that spits out the ideal job description, because you're communicating with humans, so you want something that's going to be meaningful to them. So what happens here is as you're typing or as you paste in your job listing, you're getting a score that represents how well your job listing is likely to do on a bunch of different outcomes, like time to fill and how many people will apply and how many qualified people will apply, and some guidance on the right side and overlaid on the text that augments your writing experience. So you are constantly getting this updated guidance to making your job listing better. The score and the guidance is updating in real time as you type, and that's happening automatically. So what I want to argue today is that when you want to design a system like this, the design choices are actually completely different than when you're designing a black box system. And there are kind of three characteristics here. One is the system needs to be built using features that are directly related to the concepts that humans are going to be understanding and that you want to be guiding them on. Number two, it needs to be trained on data that represents the complete universe of inputs that you expect to receive. So not just the initial input, but what people are likely to do when they're trying to follow your guidance. And number three, you need learning loops to be able to feed your users' choices and behavior back into the system to make it and the guidance better. So for anyone who was in the last session, this will look familiar. I'm also going to be using the MNIST handwritten numerals dataset as a toy example to talk about how you would build such a system. And I'm actually going to constrain it even further. I want to talk about how do we classify a 1 versus a 7. And actually further, how do I recognize that a user has input a 1 and then guide them into turning it into a 7 or writing a 7 instead? If you want motivation, you can imagine that's how many cupcakes you get if you write that number, or how many briskets if you're not into cupcakes, you know. So let's start with one of the most widely known ways to attack this problem using artificial neural networks, and specifically using TensorFlow for this. It's so well known that this is TensorFlow's, both their beginner and their expert tutorials are based in this data set. And this kind of tool is known to be really good at being able to classify these kinds of handwritten numerals. The idea, for anyone who's not familiar with it, is that we have the numeral as an array of pixel values, and through these successive layers of artificial neurons, features are being automatically learned by the system that help predict the label. And it's supposed to be kind of a loose model for how we think some parts of the brain work. So here's the code straight out of the tutorial. I'm not going to go through every line of code in this presentation, but I'll try to highlight the important parts. So there it is. You can see the accuracy. I think their metric here is just proportion of right answers to wrong answers. And it's very high. I think AUC is also around this level. And this isn't even the best that you can get with an artificial neural network on this problem. But you know, that's pretty good. OK, so we have something where we can really clearly and easily classify a 1 versus a 7. But what if we want to know now why? What's happening inside? Well, we can look at TensorBoard, which is a tool that's specifically designed to introspect on TensorFlow models. And there's a lot of information here, but if you can imagine trying to interpret this as an end user who's not an expert, you can see you actually need a lot of really specialized knowledge just to read and interact with this and be able to make decisions on this basis. So while this is great for the people who are developing the models, it's not the right tool for producing guidance for our end users. And even if we were to learn a really simple model using TensorFlow and just look at the softmax layer at the end, where we can see basically probabilities of various pixels being associated with that label, OK, this is kind of more readable to me as a human. But first of all, it's hard to tell how I would give someone specific guidance from this. And then also, because we're just flattening out all the probabilities, it kind of collapses some key information. Like, I think it makes it look too necessary to have a foot on the 7. Or it doesn't reflect that maybe you can have a foot on the 1, but then you also need to have the notch at the top. OK, so maybe one of the most predictive models is not the right way to go about this problem if we want to give guidance. So let's try a totally different algorithm that is known to be really easy to introspect on. So the idea of a decision tree classifier is you have your two classes, red and blue in this example, and at each step, the algorithm is finding the feature and the feature value that give the best separation of the data. And it produces basically a flow chart for classifying things into roughly one class or the other. And this is really easy to do in Python using scikit-learn. So here I've just cut the MNIST data set into just the 1s and the 7s. And I train a model, and hey, I'm actually getting pretty good AUC on this. Probably not ever as good as I'll get with TensorFlow, but this is decent. But then when we visualize the decision tree, even though it's clear to me what the logic is here, let's look at what it's telling us. Well, how do I get to a 7? Okay, if pixel number 378 is less than or equal to 145.5, then yes, then pixel 157, is it less than or equal to 35? Okay, clearly this is not advice that I want to give to a user when they write a 1 and I want to tell them how to make a 7. They're not going to be tweaking pixel values, and this is, even if they could follow this, it would be really a burden to try to follow. So it's time to engineer some better features. And to do this, I'm using two tools, mostly OpenCV. That made a lot of the feature engineering on this particular problem really easy, just a matter of setting the parameters that I wanted and tuning it so that it was producing the outputs that I wanted. And I used scikit-image at one point for one thing that I thought it did better than OpenCV. These are both pip installable. There's great documentation online, and so you'll be able to do all the stuff I'm doing here. So just as a reminder, we're starting with this numeral as an array of pixel values. And I want to get from that to something that lay people, that other humans can easily think about and act on. Luckily, I am a human myself, so I have some intuitions about what that might be. And when I think about numbers, some of the things that come to mind are drawing lines and drawing corners. These are the concepts that we use to think about drawing. So it would be great if we could give advice directly targeted at those concepts. So here's just setting up everything I'm going to use for this problem. And I'm keeping all of the numerals in a pandas data frame. I'm also a pandas fan, for what it's worth. So my first step is just to resize the images. They come as 28 by 28 pixel arrays, and I wanted something that was bigger so I could easily visualize and kind of debug what I was working with. So first step, when you have a noisy input, is just squint a little harder, i.e. apply some blur. So here we get, that's the original 7, and we're turning it into something that's a little more vague, a little less specific. And then I threshold it using CV2's threshold to just make it a stark black and white figure, so it's really clear where the shape is and where the edges are. And then my final step is to skeletonize it, so I'm basically thinning it down to the 1 pixel wide central structure of the numeral. And this is the point where I found scikit-image to do better than OpenCV. The OpenCV skeleton had all these branches and artifacts coming off of it. And for my purpose, I just wanted something that cleanly represented the structure of the shape. So that's the choice that I made. And there's only one little tail on there that didn't really cause any problems. And so now that I have all the steps, I can put them together into a pipeline and apply that to every image that I have in my data frame. And you can see the result at the end. So now I have these nice skeletons that really clearly and generally represent the shape of that particular hand-drawn numeral. And it's really easy because they're 1 pixel wide for me to now find lines and corners in them. Okay, so first step is line detection. Again, OpenCV has the probabilistic Huff line transform. The idea is that for each point in the image, you're basically graphing the origin and the angle of all the lines that could possibly intersect with it, and then seeing where all of those graphs intersect, and that's one way of finding the lines. And the probabilistic version just has some greater efficiency and performance. So I'm applying that. One thing I found is that this function tended to return a bunch of lines that when I visualized them, they looked like they were all right on top of each other. It seemed like extra lines to me, and I just wanted to represent what the user would see. So I had to introduce the concept of, are two lines close enough to consider equal? And for that, I just looked at, is the origin within a certain distance, and is the angle within a certain number of degrees? And if so, then I only keep one of those. So then I put everything through that filter, and I save my lines in dict form so that I can easily access the attributes like the coordinates of the origin, the coordinates of the endpoint, and the length and the angle. So here's the result. You can see the detected lines, the filtered detected lines overlaid in green, and the dictionary representations at the bottom. And now that I've done that for all my images, it's really easy to count stuff about them. And this can start to become features that I use later. So right here, I'm counting, how many are horizontal and how many are vertical within a certain amount of wiggle room. So now we turn to corners, which seemed like the next cool thing to try. This is probably the least intuitively named function in OpenCV. Instead of corner detection, it's called good features to track. So now you know what that means. I mean, they are good features to track, but I only know that after using that. And so here I'm doing a similar thing. I didn't have to do any filtering, but I want to put them into a dictionary form so that it's really easy for me to work with their attributes. And here's the result overlaid with the dict representation. And now I can count things about the corners too. So the first thing I wanted to try, besides the number of corners, was what quadrant of the image is the corner appearing in. And now that I have all these features that humans can understand without any special training, I can use those as features to the same decision tree classifier, same parameters, same depth and everything. And hey, it's still performing pretty well. And when I introspect on what the decision tree is, it's actually telling me things that I can use if I'm drawing numbers. Check the number of horizontal lines, check how many corners are in the upper left. So that's a really great first step. But there's one issue here, which is number of horizontal lines seems to be separating the ones from the sevens really well, and a little too well. I kind of know this is more complex than just how many horizontal lines you draw on the page. And when I think about what a user might do if they drew a 1 and I said, draw one more horizontal line. Maybe they'll make a 7, but maybe they'll make a capital L instead. So clearly, I'm not really reflecting everything that users could do in response to my guidance. But that could be easy to deal with. Maybe I'll just stick a bunch of capital L's into my training data and label them as not 7, and see if I can learn, okay, what makes a 7 besides the number of horizontal lines? Again, OpenCV makes this really easy to rotate an image, and here you can see an example of a 7 rotated and turned into an L. And sure enough, what comes out of this looks like it reflects the complexity a lot better. We did take a little performance hit, but I feel that this is going to reflect better what I expect to see from users as they're following my guidance. And actually, if I just add one more feature and a couple more levels to the decision tree, I can get back up above 90. So I now have a way to continue to refine and tune this model and get more and more predictive. And I'm still basing this on features that I can directly use in my guidance. So let's talk about how we would construct guidance. In this case, if we see that this is a 1, the model knows what the feature values of a 7 are likely to be given this initial input and can take the difference between the current input and the target. Once you have that, you could see how you could one-to-one map this to prose guidance that you could show a user in the UI that they could follow and have a really good chance of producing the desired input. If you want, you can also make UI decisions to kind of indicate some of the same things. It doesn't just have to be words. You can use images or highlighting to help reinforce what you're trying to guide them to do. In a system like this, you want to have a mechanism for communicating low confidence. So let's say based on our model, we can't tell whether this is a 1 or a 7, and we think it may not clearly be a 7. So that's indicated by the features that come out and the probabilities that come out. And in the UI, you can make a choice to change the way that you express that in your language or in the visual aspects of your UI. And finally, we need a way to observe what users are doing and feed that back in to what we learn. So in this case, if I give the user the same guidance that I had constructed before, and this is what they do, they draw this kind of sideways lambda, I can see, the system can see that the feature values are different than what I expected when I took the diff. That tells me that the guidance wasn't followed in the way that I expected. So ideally, when this happens, it would be great to also know the outcome of this shape. Is this a new way of writing 7? And if you write this, you're going to get the 7 cupcakes or briskets? Or is it incorrect, and is our guidance insufficient to helping a human get to the goal of drawing a 7? So now that I've shown you a toy example, I want to show you an example of a much more complicated system that's built on these principles. So this is Textio's job listing editor, and I'm going to paste in my listing. And I had an internet blip, but I'm going to paste in the listing again. And as you can see, the scores and guidance are updating as I paste it in. And then so I'm looking at the guidance and I see, okay, I need to have more bulleted content for my job listing to perform well. So if I want to add something, maybe say you need to proactively offer solutions to problems as part of this job, then the guidance is updating live in response to all the changes I made. So I added words, I added a bullet point, I added some corporate jargon here, and that's all being taken into account and automatically helping me get this towards closer to 100. And then if I want to look at the suggestions for replacing this phrase that's likely to make my listing perform worse, but the system does not have complete confidence that this is a good replacement, I have a mechanism for giving that feedback. And this is all built in Python, by the way, all the back end, and we do all our data stuff in Python. So now that you've seen this, this is the amazing team of people that I get to work with every day. And Chris Harlan, our director of data engineering, is over there in the audience, and Karen Snyder, our CEO, is even here. Really happy to see you guys. And I wanted to say, if any of this is intriguing to you, if you think it's something that you might want to work on, then come see us. We're hiring. Thank you.
Thank you very much, Olivia, for that.
Thank you.
Once again, I will be taking questions on Twitter, assuming Twitter cooperates, which is always a good hope. So while we wait for questions to come in on Twitter, where else have you seen the use of this kind of guidance other than obviously at Text.io and to try to get yourself more cupcakes?
I wish I had that system.
Yeah, I know.
I can't. An example isn't coming to mind. We may be the first people to be doing this exact kind of thing, and it's really exciting and fun to work on.
Definitely not a bad problem to have. So I saw you recommending OpenCV and scikit-learn and scikit-image. Is there any other libraries that we should probably keep an eye out for or consider using when we're trying to figure out how to do this? And at least from my perspective, also just kind of figure out when's it best for easy use of decision trees versus neural networks and all that kind of stuff.
Yeah, I think scikit-learn has so many things built in, and the way that OpenCV makes image processing, that it's really about just finding the parameters that work well for your problem. I think that's true for all of the algorithms built into scikit-learn. So and it's well documented. So that's really the core of what I would recommend.
Okay. Trying to get Twitter to refresh. It's deciding to give me hassle. No, I asked. If anyone's working on the Twitter app, make it refresh faster. All right.
Can we ask questions without Twitter?
If this fails, yes. Here we go. So one question we do have is, do you use decision trees in production, and how do you address their tendencies to overfit? Or if you even use them in production, or if you don't, what do you use?
Yeah, I'm not going to go into the specifics of what we use in Textio. I would say that I chose decision trees here because they're really easy to kind of intuitively get, even if you haven't seen them before, and they're kind of the classic example of what you would use if you want to introspect on your model. But they're not appropriate for all applications.
Another question we had was, could you talk about applying this guidance to education and learning, perhaps, or if you have any opinion on that?
To human education? So the idea is you're guiding the learner or you're guiding the teacher?
I don't know. The question
I could see, I mean, that's a really good example, though, for teaching, because if we could have a robot teach, then we would probably have that happen. But there's so much art and there's so much real-time responsiveness that goes into being a teacher. I guess, in theory, a lot of these human activities people could get access to more data and help making decisions through some kind of augmented system, the way that we're doing augmented writing.
I mean, I know personally, while I was watching your talk, watching you try to guide someone how to draw a 1 from a 7, it immediately made me think of the old meme of how to draw an owl, draw one circle, draw another circle, draw the rest of the owl. And I can see this being kind of along those lines of just teaching someone potentially how to draw and such, or help people learn how to do that sort of thing.
Yeah, and you need to make sure that you account for all the steps that they might need to follow from beginning to end. Mm-hmm. So just like you said, you can't have a feature, did they draw the owl?
Yeah, not very helpful.
Yeah,
another
really
question?
predictive though.
Yeah, exactly. Did you finish, yes or no? Another question was, do you have any guidelines for how to pick good features?
That's a really good question. I think I would start by casting the net wide. Like I said, if we're dealing with a problem where humans are going to be judging the outputs and that's part of the outcome, and that's whether it's deciding how many cupcakes to give you or deciding whether to apply to your job, your intuition about what's meaningful in that space is going to be really helpful in giving you a foundation. And then I would say, try to come up with everything you can. And one of the wonderful things about machine learning is you don't have to decide in advance what you think the weights of those different features are going to be. You can learn whether they're actually important for the problem or not.
Okay. Another question we received was, what kinds of applications do you think guidance-based ML is most relevant for? Although that somewhat goes along with the previous question. I heard someone say something. Okay, so I believe there's one question in the audience I can repeat. If you want to speak loudly enough, I can just say it again.
So in this case, you had able to replace it with an explainable model that has the same performance. What happens if they don't actually have the same performance? Neural network outperforms by a lot the explainable model.
So the question was, as Olivia showed, starting with the neural network is great and can have high performance levels, but you can't explain exactly how it works. And then she was able to build a decision tree that did have high performance and was explainable. The question was, what do you do when you can't get from the unexplainable to the explainable and keep the same level of performance? Correct?
Yeah, that's a great question. I think you can attack it from two angles. One is more feature engineering. Maybe you just haven't found the right features that are going to be predictive of the outcome you care about. Another thing is the prediction, the performance metrics that we use don't completely describe how useful our model is for whatever we're trying to solve. So it's possible that you could have a situation where you really need to be highly predictive at one end of the spectrum, and at the other end of the spectrum of inputs, you can just get by with communicating low confidence in your predictions. So if someone starts drawing squiggles and I haven't learned, I don't have that in my training data, I don't have a way of knowing what that is, but I can just communicate that that's outside of what I can give guidance about right now and maybe have some way to steer them back on track. Luckily, in a lot of these applications where your system is collaborating and augmenting the experience of the human, is your users are going to be benevolent. So they really want to get to that goal of drawing a 7. So they're going to try their best to follow your guidance, and that helps constrain the possible inputs that you can expect in most cases. Should we take one more?
Yeah.
This is more a comment that I want your reaction on. I think you're at the tip of what may be the most important problem facing neural networks for the next 20 years. They are unexplainable, they're not human. And if we completely go in the world of neural networks, we may get great predictions, but we'll lose science, we'll lose the ability to understand what happened. And what you're trying to do, it seems, is to build the bridge between the human and the inhuman, even though that's forcing you to use other modeling techniques that may not be quite as accurate, but hopefully are sufficiently accurate. But this seems to me to be like what you're on the most important problem related to neural learning going forward.
I agree, it's an important problem. Sorry,
So,
restate the statement.
So the comment was basically neural networks, because they're unexplainable, can be viewed as almost harmful to science because they're not explainable. And what Olivia is presenting here in terms of trying to make such systems explainable is really important and potentially something very important going forward. And if I said that correctly, and the question basically was, what's your response to that statement?
Yeah, I agree. This is something that a lot of people are thinking about for the reason I talked about earlier. Well, for one reason, that we're starting to apply these approaches to ever more high-stakes applications. And also for some activities like writing, I think it's really exciting that we can have a system that is partnering with the human and not replacing the human, because I think we see we can't adequately replace a human in some domains. Like we've got one more, maybe?
Yeah, there's. Someone was asking if you could actually demo Textio to show a close to perfect job listing that resulted from actual going from not so great to actually very good.
Sure. I don't know if it went from not so great, but I can show you. We make a point of making sure that all of our listings score well in Textio. So just to plug our hiring again. So you can see here some of the reasons why Textio is predicting that this listing will fill quickly. And I hope that answers the question.
Were there any other questions that happened to be that? Yes.
So I also work with trying to get people to adopt some of this kind of like we've developed models, but we need an actual person to look at them and then look at some of the found anything that helps you get people to actually use kind of this guided model more, kind of like on getting adoption of it more?
So the question was basically, how do you help drive adoption of this guidance approach?
Yeah, I think the key for us is when you're using Textio, it doesn't feel like you're interacting with a machine learning model. It just feels organic, like you're writing, and then you have all of this additional guidance and information overlaid on top of it. I would say from a user perspective, that seems ideal. What's your domain?
I'm in healthcare. So
Healthcare.
Physicians and some other.
Okay, so like diagnostics and,
Kind of more actually looking at kind of trying to identify high-risk patients.
okay, identifying high-risk patients. That's really cool. I would love to hear more about that. We have one more raised hand in the back if Twitter is not.
We can totally do that. Yep.
So this seems like a really cool platform in general for writing. I can see it expanding beyond, job postings. Do you see any challenges in maybe the potential feature space explosion of generalizing to like creative writing or something like that?
Okay, so the question was, this seems to be applicable to all kinds of writing. Do we see a risk of feature space explosion when we move to other domains? And I totally agree, and that's one of the things I'm most excited about. Any kind of writing that has an outcome, you could see how this would be really useful. I would say that's not my main concern. I would think one of the hardest things is getting good data. So we can get really good data about listings and hiring outcomes from our customers. It's harder to see in some domains that we might be really interested in how we would get the outcomes to go along with the data and how to make that process of providing data really easily. As far as the features, I would say, a lot of language has a lot of features in common, but obviously you have to refine this process based on new domains that you move to.
Okay. Yeah, I think I missed a question, but it was about applications, which I think we've covered. I believe that's everything. So unless there's any other questions in the room? Yes?
So have you ever considered using reinforcement learning for these sorts of problems where the actions are the suggestions you give, and then the rewards you get are basically the scores you give? So have you ever tried this kind of paradigm in your products?
So I think that's kind of, okay, so yes, thank you. The question is, have we tried to use reinforcement learning? I would say that's part of the idea of having these learning loops that are observing aspects of the user's behavior in response to guidance. The time scale at which we might get complete data about the outcomes is slightly different. So we have to take a number of different approaches to knit that together into this system that's going to be really predictive and performant.
And just to give everyone the 6 minutes until the next session, and if Julie's in the room, the next speaker, please feel free to come on up and get ready, and we'll keep taking questions if Olivia's amenable to it, and we still keep
Sure.
getting them. So, yes.
Prior to
Yes, and thank you again, Olivia.
Thank you.
Prior to, neural networks and recent other ML models we have, right? We used to do a lot of looking for features in problems and using that to solve it. How does this differ from that previous approach?
Right, so this is talking about the earlier days of machine learning before we had really complex artificial neural network models. And how does this differ? I would say we have the benefit of explainable features, but also whatever predictive power and processing power and complexity we need to learn a really predictive model from those features. So there can be more complexity, and it's not like we're mapping out, based on this job description, what are all the paths you could take at this time to make it to make it better. But it's still founded, like you said, on explainable features.
Yes.
This is fascinating.
Thanks.
Would it be complete madness to use one model, a black box, to do prediction, and then do something explainable to the guidance part? They would be.
Feel free to just come on and just plug on in and get ready.
Maybe you're trying to learn how to teach or something kind of guidance. You're trying to learn how to provide guidance is different than trying to score something.
Yeah, and I've heard, so the question was, could we use a black box technique for the actual prediction and another way of learning how to give guidance? And I've actually seen this mentioned in the realm of explainable AI, where you have one model that's kind of learning the structure of the other model. I think the issue you get into there is that the features may be really far away from what you're actually going to be giving guidance about. So when a human makes a change in response to the guidance, it's not directly related to what you're predicting on. And it seems like if we can do well enough using those direct concepts, why wouldn't we just use those? But I agree, that's a really interesting approach too.
Yes.
Let's try your do you have any plans on, or maybe you already have to scaling the feedback loop or the reinforcement of taking in a user's response to the guidance and feeding that back into the model and how do you scale that when the data is so large and you have very large users?
So the question is, how do we scale our learning loops when our data becomes very large? And I mean, I think if you think about any time that you need to be able to scale to predict on large amounts of data, it's similar techniques to what you would use. It's no different from that problem, I would say.
Yeah.
Hi. So you mentioned that there might be other domains where finding data is harder, and I guess there has to be an intersection of, like market demand. What kind of domains were you thinking of?
Well, so the question is, what other domains might we think about where data might be harder to get? We do have a recruiting mail beta right now. So that's another example of some place where you could imagine the outcome is, will someone respond or will someone ultimately get into the hiring pipeline? And maybe the data is a little bit harder to get because job listings are public by their nature, but mails are sent privately. So that's a unique problem to that domain. I should probably let the other speaker get on. But thank you guys so much.
Thank you.
I would love to talk to you more after the session.